Welcome to the presentation on comparators. Here we see the standard 741 op-amp or standard op-amp used as a comparator. If you notice, because of the large gain, that if it doesn't have negative feedback, we have no control over the gain and it will go to maximum. So no matter how small of a signal we put into the non-inverting side, it's going to go to the positive rail, which is some percentage of the power supply. If we put a minus in the non-inverting side, it's going to drive it to the minus power supply, some percentage of the maximum of the voltage input. Here we see an op-amp used as a comparator, and what we have is a +4 voltage going into the inverting side, and we have ground or 0 volts going into the non-inverting side. So the rule of the comparators is the largest input will drive it to that rail. Since we have 4 volts here and 0 volts here, 4 volts is greater than 0, so that would drive it to the minus rail, which 14 volts is pretty close to the 15 volt power supply. Here we have another example of an op-amp used as a comparator. We have +4 going into the non-inverting, 0 going into the inverting, 4 is greater than 0, so we're going to drive this to our positive rail. So +14 volts is pretty close to our 15 volt power supply. Here we have a little tricky comparator here where we are putting in minus voltages. Well, on the timeline or the number line, -5 is lower than -4, so -4 is greater, so we're going to drive this to the minus rail, which -14 volts is close to the -15. Here we see LM339, which is a actual comparator designed to be a comparator, and it has an open collector transistor inside of it. Okay, so we have our comparator, and this one will run between ground and 9 volts, and we have this open transistor where we need a pull-up resistor in order to get a high out of it. Okay, so when this goes on, it's actually pulling it to ground. Okay, so without this pull-up resistor, when we go high, we won't get a signal out, so it always needs some kind of a pull-up resistor. This is real good for relay coils and things like that, lights, because we can make this voltage anything. We could actually put 5 volts on this pull-up resistor and make it a logic device.